Imagine a future where computers can solve problems in seconds, problems that would take our best computers today thousands of years to solve. This is not just a dream, but a reality that is slowly unfolding before our eyes. These problems take our best computers today thousands of years. Supercomputers, the giants of classical computing, are already pushing the limits of what we thought possible. This is the promise of quantum computers. They are not just faster versions of our current computers, they represent a completely new paradigm in computing. They're not just faster versions of our current computers. Quantum computers use the principles of quantum mechanics to process information in ways that classical computers cannot. They are a completely different way of processing information. Instead of bits, they use qubits, which can exist in multiple states at once, allowing for exponentially greater processing power. Supercomputers, on the other hand, represent the peak of classical computing. They are the workhorses of today's data-driven world, capable of performing billions of calculations per second. They are giants, often filling entire rooms. These machines are essential for tasks that require immense computational power, such as climate modeling, simulations, and complex data analysis. Supercomputers excel at crunching massive amounts of data quickly. They are indispensable tools for researchers and scientists who need to process and analyze vast data sets. Both quantum computers and supercomputers are revolutionizing science and technology. They are complementary technologies, each with its own strengths and applications. They allow us to push the boundaries of human knowledge and understanding. As we continue to develop and refine these technologies, we are entering a new era of computing that promises to transform our world in ways we can only begin to imagine. Quantum computers operate on the principles of quantum mechanics, a field that defies our everyday understanding of reality. Quantum mechanics is the strange and counterintuitive world of atoms and photons, where particles can exist in multiple states at once and influence each other instantaneously. One key principle is superposition, which allows particles to be in multiple states simultaneously. Imagine a coin spinning in the air, not yet landed as heads or tails. In the quantum world, it can be both heads and tails at the same time. A quantum bit, or qubit, can be in both states at the same time, vastly increasing computational power. This allows quantum computers to explore many possibilities simultaneously, solving complex problems much faster than classical computers. Another principle is entanglement. Two entangled particles are connected in such a way that the state of one instantly influences the state of the other, no matter the distance between them. This connection is mysterious and instantaneous, defying the classical notion of locality. It's like they can communicate faster than the speed of light, a phenomenon that Einstein famously referred to as spooky action at a distance. Entanglement lets quantum computers make connections that classical computers miss, opening up new frontiers in computing, cryptography, and beyond. The potential applications are vast and transformative, promising to revolutionize industries and solve problems previously thought unsolvable. Supercomputers, unlike quantum computers, rely on classical computing principles. They use a massive number of processors working in parallel. Think of it like a team of cyclists working together in a race. Each cyclist represents a processor. No single cyclist is the fastest, but together, they can achieve incredible speeds. Supercomputers excel at tasks that require brute force. They can perform trillions of calculations per second. This makes them ideal for simulating complex systems, like weather patterns or the human brain. Imagine you want to find a specific grain of sand on a beach. A supercomputer would be like having 1,000,000 people search the beach grain by grain. A quantum computer would be like being able to analyze all the sand simultaneously. You would find the grain instantly. This illustrates the fundamental difference in processing power. Supercomputers excel at handling complex problems with many variables. Quantum computers are better suited for problems with vast numbers of possibilities. Section 5. Solving the unsolvable, where each computer excels. Supercomputers are like powerful engines. They power through complex calculations and simulations. They are used in weather forecasting, climate modeling, and financial analysis. Quantum computers are like delicate instruments. They are best suited for specific tasks. These tasks include drug discovery, materials science, and breaking encryption codes. Both technologies have the potential to revolutionize their respective fields. They offer solutions to problems that were once considered impossible to solve. Section 6. Real-world wonders applications across industries. Supercomputers are already changing our world. They help us understand climate change, develop new materials, and design safer cars. In medicine, they are used to develop personalized treatments and accelerate drug discovery. Quantum computing is still in its early stages, but its potential applications are vast. It could revolutionize medicine, materials science, and artificial intelligence. Imagine new materials that are lighter and stronger, or personalized medicine tailored to your DNA. Section 7, the future unfolds. Advancements on the horizon. Supercomputers continue to evolve, becoming more powerful and energy efficient. Researchers are working on exascale supercomputers. These computers can perform 1 quintillion calculations per second. That's a 1 followed by 18 zeros. Quantum computers are also rapidly advancing. Researchers are working to build more stable and scalable quantum computers. The goal is to create quantum computers that are accessible to more researchers and industries. Section 8. A universe of possibilities inspiring the next generation. The world of computing is on the verge of a new era, one that promises to revolutionize the way we live, work, and interact with technology. Quantum computers and supercomputers are opening doors to a future filled with endless possibilities and groundbreaking innovations. This future holds unimaginable possibilities, from solving complex scientific problems to creating new forms of art and entertainment. These technologies will transform industries, accelerate scientific discovery, and reshape our world in ways we can only begin to imagine. It is a time of great excitement and opportunity, where young minds can explore, innovate, and contribute to a rapidly evolving technological landscape. We encourage you to learn more about these incredible machines and the amazing things they can do, as they hold the key to unlocking a future full of potential. The future of computing is in your hands. Embrace it, explore it, and be a part of the next generation of innovators and leaders who will shape the world of tomorrow.